Welcome, everyone. Welcome to the Frank Islam Athenaeum Symposia series. My name is Bess Vincent, and I'm an Assistant Administrative Dean supporting the Germantown campus. In the past year, I've worked to support the Athenaeum events, and we're glad to see so many of you here tonight. We thank you for coming to what will surely be a fantastic talk and discussion. We're also busy building the Fall 2018 speaker series, and we invite you to sign up to receive emails about upcoming speakers. You can sign up on our mailing list by visiting the website at montgomerycollege.edu/Athenaeum. Before we begin, I have a few practical notes. If you're a student who may need a certificate of attendance for being here today, they will be available at the exits after the talk. We do ask that you silence your cell phones and turn off all screens to avoid distractions for others. Also, there will be an opportunity for questions and answers following the presentation. There are 2 microphones placed in the aisles. At the designated time, we will invite those of you who wish to ask questions to make your way up to one of the microphones, so please plan accordingly. In addition, after tonight's presentation, we invite you to continue the discussion upstairs, where we will have a reception to celebrate what has been a successful Spring 2018 speaker series. We would like to take the opportunity to thank several people whose efforts helped to ensure the Athenaeum's success. First, I would like to acknowledge Dr. Joanne Bagshaw, who served as the co-coordinator for the Athenaeum before going on sabbatical, and Dr. Tiffany Banks, who served in this capacity for the full academic year. They've worked tirelessly to find great speakers and to promote them, and we cannot thank you enough for your service to the series and to Montgomery College. And we do have a small token of thanks that we will give to you at the reception, so if we can take a minute to... We would also like to thank the Media Resources staff, the Office of Communications, the MCTV crew, and the MC Bookstore for their contributions to these events. Media Resources has worked through some impromptu sound changes, working quickly to build a new sound system from scratch in an event earlier this semester. MCTV has helped to promote our events and to broadcast them through Facebook Live. In fact, they're filming tonight, so everyone turn around and wave to this camera over here, our audience at home. Coupled with the efforts of rock star administrative assistants like Iris Harrigan and Mary Murphy Snyder, and student workers like Maren Williams, Daniel Isaac, Christopher Kohler, and Muriel Tedigan, this year's events have run smoothly and benefited many in our college and community. We would also like to take a moment to provide special recognition to Montgomery College's very own classically trained pianist, Nancy Nyland, our reference librarian, and William Chang, professor of music. They've helped to welcome Athenaeum audiences with pre-event music, and we have a small token of appreciation for each of you as well. These kinds of events are also successful because of the support they receive from administrators at the college. We're continually grateful for the support shown by Margaret Latimer, Vice President and Provost of the Germantown campus. Tonight, we also want to take an opportunity to recognize Dr. Monica Trent, the Dean of ELAP, Linguistics, and Communication Studies, and the Humanities Dean who has overseen the Athenaeum for the past several years. Dr. Trent has provided exceptional leadership for the Athenaeum coordinators, providing steady and consistent support during periods of transition. Dr. Trent has accepted a position as the Provost and Vice President of Academic and Student Affairs at Delaware County Community College in Media, Pennsylvania, beginning June 18th. While we wish her all well in the new opportunity, her service to Montgomery College and the Frank Islam Athenaeum Symposia will be sorely missed. As a token of appreciation, we would like to present her with a beautiful vase. It reads, "In recognition of Monica Trent, who helped the Athenaeum to flourish." Tonight, we're fortunate to have Ilissa Ocko here with us to deliver a presentation titled Climate Change, What is Happening and What Can We Do About It? When the coordinators first informed me that she would join our speaker series, I was very excited, especially given my own background and interests. I grew up in southern Louisiana, and 12 years ago, I lived in New Orleans, which was devastated by Hurricane Katrina, a strong Category 4 storm that overwhelmed the city's pumping system, leading to major levee breaches and leaving 80% of the city under at least 5 feet of water for over 2 weeks. Over 2 months later, when I was allowed to return to the remains of my home, I was struck by the residue that the receding waters had left behind. Like the ring that remains on a particularly dirty bathtub, all of the buildings and fences carried this stain, like a scar to remind us of what we had survived. What's intriguing about those stains, though, is that it provided visible evidence of the pollution in our world, comprised of oil, gas, household and industrial chemicals. This water line served as a tangible reminder of the invisible risk that comes with environmental neglect. After nearly a year of water, sediment, and soil sampling, the EPA concluded what many of us already knew, that there are some serious areas of contamination in the New Orleans area. Unfortunately, the majority of it predated the storm, and as such, the EPA was not responsible for any type of remediation. And while this sort of conclusion begs discussion about classic environmental justice issues, whereby lower-class communities and communities of color stand at disproportionate risk to environmental issues, natural disasters like Hurricane Katrina expose new axes of power and inequality in New Orleans. Along with the familiar dichotomies, black and white, rich and poor, young and old, native and Yankee, we can now add flooded and dried, roofed and roofless, insured and uninsured, and gone, returned, and never left. As we push into the 21st century, into a post-industrial technological society, we must continue to define these natural disasters as social issues with real consequences for the people who experience them. I'm grateful that our speaker tonight can help to deepen our understanding of climate change and to consider ways we might affect change. Dr. Ilissa Ocko is a climate scientist at the Environmental Defense Fund, where she pursues climate science research and provides scientific guidance for climate change communication and policy. She earned a PhD in atmospheric and oceanic sciences from Princeton University and a Bachelor of Science in Engineering and Earth Science, System Science, and Engineering from the University of Michigan. She also holds a certificate in Science, Technology, and Environmental Policy from Princeton's Woodrow Wilson School. Her research focuses on the long and short-term climate impacts of several greenhouse gases and aerosols. Sounds somewhat complex. Luckily, though, Dr. Ocko is also deeply committed to communicating science to non-experts using plain language and powerful visuals. She speaks regularly, having recently represented the U.S. in an international science communications contest. She also writes several blogs for sites, including the Environmental Defense Fund, the Plain Spoken Scientist, and the Toast. In her presentation tonight, Dr. Ocko will speak about Earth's climactic past, scientific views on the current warming trend, including how it affects societies and ecosystems, and what might be done to affect change. She will also share highlights of her research on the short and long-term climate impacts of greenhouse gases and aerosols and mitigation issues. Fellow members of the Montgomery College community, Dr. Ilissa Ocko.
Thank you for that introduction. I think my mic is on, yeah? Gonna go with yes. I'm really honored by the opportunity to speak here today with all of you. I consider climate change to be the greatest challenge of our time, and I know I'm not alone in thinking that. And so the fact also that it is terrible weather outside and you all made the trek here today is a testament to really caring about this issue that we're facing as a world and trying to do something about it. How many people have heard of the Environmental Defense Fund? Okay, so a good number of you. But for those who aren't familiar with EDF, it is an environmental advocacy organization based in the U.S., but we have offices across the world. And we work with a combination of scientists, economists, lawyers, and corporate partnerships to try to find the most practical, long-lasting solutions to some of today's most pressing environmental challenges. Now, those environmental challenges could be fishing and the issue of fishermen not having enough fish and trying to figure out how to keep the amount of fish in the ocean sustainable while feeding society. It also has to do with toxic chemicals and trying to limit those from being in the products that we use every day. But it also has to do with climate and energy issues, which is how my involvement with EDF comes to be. So I am a climate scientist, and I pursue original research. I use climate models to better understand how different types of pollutants impact warming and over different time scales and from different activities. But I also am directly plugged into a lot of climate policy-related activities, working with cities and at one point the federal government to try to push forward a lot of different actions that we can take to address our emissions of greenhouse gases. And so using this unique combination of scientists, economists, and policymakers, and with corporate partnerships, EDF is able to make some real change. And just a little historical note of how we developed in the 1960s as the outcome of the DDT crisis. The scientists who discovered that DDT was a problem worked with a lawyer to ban DDT nationwide. And so that was the start of the Environmental Defense Fund. And today we are over 600 people worldwide working on issues. So today I'm going to talk to you about what is happening with climate change, why it's happening, all the different impacts that we're seeing across the world, but also, of course, what we can do about it, all the different actions that are being taken now, and then we'll definitely leave some room for questions so that we can have more of a discussion about everything that I've presented you with. So I'm going to start off with the basic fact that we have been monitoring Earth's temperature for over a century. So scientists measure temperature over land by having thermometers in cities and remote locations and setting up measurement networks across the world. We also measure temperature in the oceans with sensors on ships and buoys and underwater gliders, just to name a few. There are a lot more instruments than that. We also measure temperatures in the atmosphere. We have instruments on balloons and aircrafts, and most recently we have satellites that are able to look at the atmosphere, but also the land and the ocean. And what multiple independent scientific institutions do worldwide is collect all of the data from these various measurement techniques and string them together into a global database of average temperatures. And what we found from putting together all of this information is that there is a very striking warming curve. We see over the past century that temperatures compared to an average 20th century temperature are just rapidly increasing. And so where we are today is around 2 degrees Fahrenheit warmer than where we were, and in terms of what the average is. And this is very concerning, and we're seeing this warming trend not just from the surface of the Earth. That's what this plot is. This is NOAA data. It may as well be NASA data or data from European agencies. It all looks the same. We also see this trend in the upper ocean, the deeper ocean, and the lower atmosphere. So the Earth in its entirety is warming up. The planet is reacting dramatically to the change in temperature. So we see this warming in many other ways beyond just measurements using thermometers. So we see sea ice in the Arctic completely decreasing over the past few decades. It has halved in its extent, so it covers a lot less area than it used to. This is really worrisome for wildlife that need the sea ice for their different behaviors and life patterns. For example, polar bears rely on sea ice to break up their swims when they're hunting for food. And so now with some of the sea ice disappearing, the polar bears are drowning. And we actually see this most with young polar bears that aren't able to keep up. And this is something that is, as you can imagine, really devastating. But another thing that happens when you melt some of the sea ice is you're exposing these dark ocean waters below the bright ice. And what this does is absorb even more sunlight and heats up the area even more. We also see almost all the glaciers worldwide are shrinking. There are striking images from all over the world that show before and after photos of what it used to look like and what it looks like now. And so we see this in Greenland and Antarctica and the major ice sheets, but we also see this on land glaciers and mountains. Communities survive on the fresh water that's coming from these glaciers. Even just in the U.S., in the northwestern part of the U.S., the snowpack is melting around a month earlier than it used to. And so this is really devastating for communities who need that water, and that water is gone a lot quicker than it otherwise would be. So some of the melt from the melting of the ice goes into the oceans, and it raises sea level. And so sea level rise is obviously a very big deal. It can seem very slow and gradual, but then you have a storm and all that excess water just gets pushed on shore and floods communities and damages infrastructure. So for the global average, sea level has risen by over half a foot since pre-industrial times. But for the northeast coast of the U.S., it's actually around a foot of sea level rise that we've already had. So we see this for hurricanes like Hurricane Sandy. We see a lot more flooding than we otherwise would have because of the sea level rise. The sea level is also rising because the ocean temperatures are getting warmer. And when you have warmer ocean molecules, they expand. And so the water's now just taking up more volume than it would have otherwise. And so this is contributing to sea level rise, but it's also contributing to affecting wildlife in the ocean. You have warmer waters that some species can't tolerate. And so we're all very familiar with coral reefs and their vivid colors. Well, the colors of the coral come from the algae that live on the coral. And the algae gets stressed when it gets too warm, so they leave. So now you have corals that are bleached. But this is a big deal, not just in terms of aesthetics and what it looks like, but because the algae are the source of food for the corals. Corals are animals. They're not plants. And so they rely on eating the algae. And so now we have corals that are starving worldwide. The Great Barrier Reef has seen over 90% of its coral reef structure dying. 50% has been pronounced already dead. This is something we can see visibly. It's not hard to detect. And even just regular people going on vacation, going snorkeling, see this happening. And finally, extreme events. They've gotten a lot worse. That could mean that they're more intense, or they're more frequent, or they last longer. It depends on the type of event. But we have had the number of billion-dollar weather and climate disasters has more than tripled since the 1980s. This is incredibly expensive and has also led to many deaths. In 2017 alone, we had 362 people killed from extreme events, and this caused a record $306 billion in damages. So this is an economic challenge, too. We've also seen wildfire season last 2.5 months longer than it used to in the early 70s. We see more rainfall and heavy downpours. In our part of the U.S., there's over 70% more rain and heavy downpours. That is a tremendous amount of extra rainfall that we're getting. And this is because in a warmer world, the moisture is evaporating, and so we have more moisture in the atmosphere, so that when it does rain, we have more rain in it. And so this has obviously led to a lot of flooding. Heat waves also all over the world have gotten a lot worse than they used to be. But everything we just talked about has pretty much all happened in the last century. And a century really isn't that long. When we think about the history of the entire Earth, a century isn't that long. If we took the history of the Earth and we squished it into one calendar year, which would mean that January 1st was the day the Earth was created, it isn't until the very last second of the last day that we started recording temperatures of the Earth. So how do we really know that this climate change is a big deal when we've only been monitoring it for such a short period of time? To give you some context here, the dinosaurs roamed the Earth around the middle of December, and April 24th, today's date, there was no oxygen in the atmosphere, and the Earth was entirely ocean. So land was yet to form. I think land formed in May. So scientists have uncovered many different ways to extend this temperature record back in time, so that instead of us only knowing what the Earth's temperature was like for the past century, we can go back thousands and thousands of years into the past to really get an idea of how different is what's going on, is what is happening today. Is it a big deal? Should we be concerned? Is this normal? To answer all those questions, we really need a larger time series of data. And so we have clues in nature all around us that can tell us what the climate was like in the past. So we can extend this temperature record back thousands of years by using Treering Data. So we all know that you can measure how old a tree is based on how many rings it has. But the thickness of the rings is indicative of the climate. Was it warm that year? Was it wet that year? So we're able to look at the trees and the tree rings and see what the temperatures looked like back a couple thousand years ago. Then we can look at ancient air and water trapped in ice below the surface in the polar regions. And that can tell us what temperatures looked like back to nearly 1 million years ago. And then another method, and again, these are not exhaustive, there are many more methods than this, is looking at ocean sediments. Sea creatures die, they fall to the bottom of the ocean, and then they just kind of pile up over time. We can take cores of those sea sediments and look at their chemical structure, and that gives us an idea of what climate looked like up to 500 million years ago. So scientists work on all sorts of these aspects with different techniques in different areas, and what they've been able to do is string together a temperature record of what the temperature looked like in the past, well before we actually started measuring temperature in real time using thermometers and other sensors. So what we found, if we go back in time, is that the climate was relatively steady for around 10,000 years, and then it got a lot colder. Around 20,000 years ago, this was the last major ice age. So a lot of this data would have come from tree rings in the beginning, but also from ice cores. We can go back farther to around 1 million years ago. We see a lot of oscillating shifts in temperature during this period. This data comes from ice cores. And then if we go back farther to 5 million years ago, and 65 million years ago, and even 500 million years ago, we see that the Earth was a lot hotter than it is today. These records aren't perfect, but they're a really good idea of what the climate looked like before. So what can we really learn from this? What does this tell us? So the first thing this tells us is that human civilization has thrived in a period of relative climate stability. So if you look at this box that says number 1, the temperatures really haven't changed much over the last 10,000 years, where modern civilization was able to really thrive and come into its own and be what it is today. So it's definitely concerning that we may breach that threshold. That is definitely a cause for concern because we've been able to live in a period where it was so stable. But secondly, shifts in climate seem to happen all the time and well before humans evolved. And so what does that really mean? What does that mean for why the climate's all of a sudden changing today? Is this just another change that just happens to be happening right now while we're here? What does this mean? So in order to answer these questions, we need to look at what controls Earth's climate. Because what makes the temperature what it is? If the temperature keeps fluctuating, why? What's controlling that? So it's basically a balance between incoming sunlight and outgoing heat. If we didn't have outgoing heat that was radiating from the Earth, then we would just boil and boil because we'd keep absorbing sunlight. So it's this balance between the sunlight we get from the sun and then us releasing that heat back out into space. But there's a number of different factors, both internally and externally, that change how much sunlight we end up getting and how much heat actually ends up getting released to space. So the first factor is the sun. Obviously, how much sunlight the sun is putting out will influence our temperature on Earth. And so that's something that we've been measuring for a really long time, trying to understand how the different wavelengths of sunlight change over time. The second aspect is the surface of the Earth. A really dark surface, like the rug I'm standing on right now, would absorb more sunlight. But the lighter wood on the floor here would reflect more. So what is the makeup of the Earth? The dark ocean waters absorb, the deserts and the ice reflect. All of that impacts how much sunlight we end up actually absorbing on the Earth. And then there's a number of different things that live in the atmosphere. And they can interact with sunlight, they can interact with heat. Some scatter sunlight back out to space. Some of those can be particles from volcanic eruptions or even just clouds. When it's sunny out and there's a big cloud in the sky, obviously you can tell that it's blocking the sunlight. It's being reflected back out into space. But we also have greenhouse gases. And greenhouse gases are kind of like this blanket around the Earth, and I'm sure you've heard that analogy before. And they keep it cozy. They keep some of Earth's heat in the Earth system, and they prevent it from escaping to space. And finally, the ocean is very important because the ocean redistributes heat in different places. So based on the ocean circulation patterns, it also affects the temperature of the Earth. So for example, if we got rid of this natural blanket that we have around the Earth would be completely frozen. It would be 60 degrees Fahrenheit cooler than it is today, and not good for human life. So greenhouse gases are great. We need them. They've been there all along. And this just shows you that when any of these factors change, so does the climate. If we take out the greenhouse gases, the Earth would freeze. So as all of these different factors change over time, and they do, so does the climate. And so if you looked at the temperature record that I showed you going back 500 million years, it's each time that the temperature fluctuated, scientists have mapped that to a different factor that was changing. Maybe it was the Earth being farther away from the sun at that point. Maybe it was a lot of volcanic eruptions happening. There are different things that we've been able to piece together to understand why the climate changed in the past. But the question is, what is changing today? And so we monitor all of these different factors. We've monitored them long before we even knew climate change was a thing. It's part of Earth science. It's part of space science, studying the different things around us. And a very detectable trend from the instruments and measurements that we use is that greenhouse gases in the atmosphere are increasing. And what this means is we are thickening this blanket around us. We are trapping more heat in the climate system than we should be. Less is escaping to space, and so the Earth is heating up. And so that's something that we've been able to detect, that out of all these factors, that is the one that is considerably changing. And if we look at some of the measurements of greenhouse gases and how they've increased, they align very well with increases in the temperature trend. So here is how much CO2 concentrations in the atmosphere have grown since the Industrial Revolution. They've grown by around 40% from then until now. And methane, another very important greenhouse gas, has grown by over 100% in its concentrations. So the increases in greenhouse gases really aligns quite well with the warming trend. And so scientists are very confident that the cause of the increasing greenhouse gases is humans. This is something that we've been studying for around 200 years. It's a science that isn't appreciated as much. We look at smoking causing cancer, and that is something that scientists studied for around 50 years, and there was an overwhelming amount of evidence that, yes, smoking causes cancer. Well, we are just as confident that humans cause climate change as we are that smoking causes cancer. And we've been studying it for even longer. And this is what isn't appreciated enough, how much work has gone into actually understanding the cause of the excess greenhouse gases in the atmosphere. So there are a number of ways that we know that it's humans. And so the first is by just ruling out natural factors. Not only do we look at factors like the sun and volcanic eruptions changing, which I mentioned earlier, but we're also looking at how different factors that influence the amount of greenhouse gases in the atmosphere have changed. There's a lot of natural things. Plants breathe in carbon dioxide and breathe out oxygen, for example. And so how much are plants taking in? Are they taking in more? Are they giving off more? Are, the different animals that also breathe out CO2, how much is that affecting the greenhouse gas balance in the atmosphere? So there's all these natural ways that greenhouse gases are released and taken up in the biosphere, in the oceans. Oceans also take in CO2 and release CO2. So all of that is also being monitored. And we've been able to rule out that any type of major changes with that are playing a role. They're not. They seem to be relatively stable, and it seems to be forests, for the amount of CO2 that they intake, they're releasing out an equivalent amount. So that's not it. But we also know simple chemistry principles that we've been working on since the 1900s, and any of the chemists in the room would know that when you burn a carbon-based material, you are going to be emitting some sort of carbon molecule, and you usually end up emitting CO2. You emit a number of other particles as well, but carbon dioxide is the simplest compound structure that you can get, and most of that ends up being released in terms of CO2. So we know that a lot of the burning, we burn a forest, if we burn wood for our fire to cook our food, it's very much common sense that this is emitting CO2 into the atmosphere. In the 1950s, we started establishing methods to actually measure these emissions at a larger scale, from factories, what are we emitting, how much is actually coming from these activities. Before then, we could use mathematical expressions to try to understand, well, if we're burning this much, we should be emitting this much. But now we started really understanding, okay, here is a smokestack. How much is being emitted from that? Also in the 1950s, we started looking at the types of carbon dioxide in the atmosphere. So carbon dioxide can have a number of different neutrons in its nucleus. And so depending on the neutrons, it can be a lighter form of carbon dioxide, it can be a heavier form of carbon dioxide. And so we're able to look at how the composition of those different CO2 atoms are changing in the atmosphere. The molecules are changing in terms of, is it the lighter one, is it the heavier one? And we're able to figure out that a lot of that extra CO2 that we have in the atmosphere now is coming from ancient plants. Ancient plants, another name for that would be fossil fuels. So it's a very complex interaction, and I'm happy to talk with some of you about it later if you want to know more about how we actually know that it's coming from ancient plants and how all of this works. But that is another piece of evidence that it's coming from human activities and not from some other natural source of greenhouse gases. We also have built very sophisticated computer models that take all sorts of mathematical and physics algorithms and basically create a virtual world. Using this virtual world, we're able to isolate different parts of the climate system and change the inputs to see what does that mean for the climate. For example, if we take humans out of the equations, if we take out all of the emissions from human activities, what does that mean? And what it shows is that when we add in all the data we've collected from the natural factors, the climate really, there would be some wiggles, but it really wouldn't have the warming trend it's having now. That warming trend is entirely created by including the emissions from human activities. And finally, in the 1970s, we started developing these very intense databases and inventories to actually monitor how much of these activities are we doing, how much, in this country, in that country, for this activity, for that activity. We started keeping track of all we were emitting. And so that just enabled us to have more data and understand better how much of these greenhouse gases we're putting into the atmosphere. So scientists all over the world, tens of thousands of them, analyze all of this evidence for themselves, and nearly all of the scientists have come to the conclusion that there is no other explanation for climate change today besides human activities and the emissions that are created from them. And dozens, if not hundreds, of scientific societies from around the world have put out statements to say that, yes, climate change is a problem, it's real, and it's caused by humans, and we need to do something about it. So something that I also think gets lost in the conversation a lot is that it is really good news that we know that it's us, because that means it's in our control. Remember our friend the dinosaur? He wasn't so lucky. It's very likely that he was wiped out by an asteroid. That is out of his control, and it changed the world that he knew. For us, there is something, very dramatic happening, but we're in control of it. We know that it's us, so we also know that we can be part of the solution. To me, it would be much scarier if we concluded scientifically that it's not human activities, it's some other natural thing happening. How would we solve that? That is way more challenging to me than knowing, oh, hey, it's these activities in these countries, we know what we need to do. Of course, the flip side to that is it also means that climate change will get worse, because as population keeps expanding and we are developing more and more nations with energy sources, we're just going to keep emitting more and more pollutants into the atmosphere. So we expect temperatures to rise by the end of this century by over 7 degrees Fahrenheit. For the Northeast U.S., the projection is 10 degrees Fahrenheit. What this means is that we will obviously have less ice. We will have more sea ice melt in the Arctic. We will also have I think projections show that around mid-century, we expect the Arctic to be sea ice free during the summer. That means that opens up a lot of dark oceans to absorb sunlight and to warm up even further. But it also has geopolitical implications because it opens up a lot of shipping routes between countries that normally couldn't travel across that part of the world in terms of the shipping routes. And so there are concerns with that. We also expect the glaciers to lose around 85% of their volume by the end of the century. And that is really sad and difficult to deal with for all of those communities that rely on those glaciers for fresh water. We also expect the snowpack in the northern hemisphere in springtime that also supplies a lot of communities with water to decrease by 25% by the end of the century. We expect sea level to rise by anywhere between 3 feet and 6 feet by the end of the century. We expect Category 4 and Category 5 hurricanes to double by the end of the century. The area that will get hit the hardest is projected to be the northeast U.S. And we expect the amount of land with water stress to double by mid-century. And finally, we expect wildfire season to keep getting worse. We expect the area of land in some places to see 650% increase in the amount of land that will be burnt from just a few degrees of warming. And so these are all the physical changes that we expect the climate to have from the warming, from the greenhouse gases. But how does this actually affect society and ecosystems? That is what we really care about, right? How does that affect our lives? How does that affect the ecosystems around us? And that's something that there's a lot of active research into. What does this mean for dairy yields? What does this mean for corn in Africa? There's just a number of different areas of life, the things that we really care about, that we're trying to better understand what this means for the future. And so I will give you now just some ideas of what we are most concerned about. And I have a cheat sheet so that I get these things right, because honestly, there's more research all the time about this. Okay. So sea level rise obviously will be a really big deal. We expect millions of people in dozens of cities worldwide to be affected by this. In the U.S., we expect $5 trillion in coastal damages by 2100. This does not include Alaska and Hawaii. We also expect a lot more flooding, partially from sea level rise, but also from heavy precipitation events getting worse. In the Gulf Coast region, 1/3 of the roads between Alabama and Houston would be permanently flooded with just 4 feet of sea level rise, and we expect as much as 6 for our worst case scenarios. This is a really big military issue, and the military has acknowledged this. This affects security when you have different countries near each other fighting for water resources, but also in terms of extreme events, which we had so many of them this past year. You need disaster relief. You need all of these food supplies and help getting people trapped in their homes, on their roofs. And so it is a tremendous effort to rescue all of these people. And so this is a major issue for a lot of our disaster relief efforts. And not to mention refugees, people who are displaced, they lose their homes, people who have to relocate in general because there's such a bad drought they can't live there anymore. It's just a major challenge for communities worldwide. And as you can expect, there are a lot of communities that get hurt more than others, and usually those are not the communities that are contributing the most to the problem. We've already seen communities in Alaska and in islandic villages in, I think, the Pacific that are having to relocate coastal erosion from sea level rise, flooding. They have to completely relocate their villages because of what's going on. We also see a lot of crops struggling to produce the same amount of crop yields that they were getting from being in prime conditions that they were used to. We have a changing climate. We have changing precipitation patterns. I think in the northeast U.S., we have around 10% more precipitation now than we did a few decades ago. And so all of these shifting patterns make things less predictable for farmers, but also make it tougher for crops to grow in certain conditions when they were used to other conditions. And so something that has been projected is that food prices may increase by 80% by the end of the century. And so obviously with less snowpacks and with less mountain glaciers, this will affect water resources for communities, but it also affects water resources for animals who rely on, these puddles of water to survive. When those dry up, where do the animals go? They're not as smart as us. They're not as capable of finding water in the ways that we are, of flying it in. So it's a really big ecosystem challenge in terms of what happens to the water as the world gets drier in many parts of the world. Something we haven't spoken about yet is that around 30% of the CO2 that we emit into the atmosphere ends up in the oceans. It then reacts with other compounds to make carbonic acid, and now we have a more acidic ocean. Today, the ocean is around 38% more acidic than it was in pre-industrial times, and we expect it to be 80% more acidic by the end of the century. This can dissolve shells, it dissolves corals, but it also disorients fish who rely on certain senses when they're born, for example, to find food, to find shelter. It can be very disorienting being in more acidic waters. So this is a huge challenge for ecosystems in the oceans. We also see mosquitoes traveling to new locations, coming to new territories, people that aren't used to the diseases that they're carrying. We've even seen that with Zika. Zika's been around, but not in the parts of the world that it traveled to recently. And it's traveling more and more. And when you have warmer temperatures, you have mosquitoes that breed more. You have incubation of the diseases inside the mosquitoes quickening up. So now a mosquito may be alive longer with an active disease inside of it, whereas beforehand it would have died before that disease fully incubated. And so this is a major challenge that scientists are looking into, and projections show that 200 million more people will be at risk for malaria by mid-century, just from warming temperatures. There's other health effects too, like heat stress. Billions of elderly people will be exposed to heat events by the end of the century. That is a major cause for concern. It already has killed a number of people, just heat wave events that we're seeing pop up across the globe. And then even just pastimes, things that we love, skiing and snorkeling and scuba diving, just going to the beach. All of these parts of life that we enjoy are being threatened. And that, threatens us as the people who enjoy them, but think about the communities there that rely on that for their economy. There was very recently a famous ski resort in Colorado was closed, and the owners cited because of climate change. They can't sustain the ski resort anymore because there's not enough snow. It's very expensive to make your own snow. And this is a facility where many Olympic athletes had trained. So it's very devastating to see these things close. And finally, all of these things cost a tremendous amount of money. And so that is a major concern economically. And when people say, oh, it's too expensive to, stop emitting greenhouse gases, if you add up all the costs from all of these traumatic situations that could unfold unless we change our course, it is astronomical how much money it could cost us. So what can we do to stop this? First thing, super easy, we need to reduce emissions. Emissions keep going up, we need them to go down. Very simple. What's not so simple is that There are a number of different pollutants that contribute to this problem. We hear about carbon dioxide the most. I've even talked about carbon dioxide the most. If we look at how much warming is coming from all the different pollutants we emit, carbon dioxide only accounts for around half of the warming we're experiencing today. So that whole other half of warming is coming from other pollutants, like methane. Methane contributes around 25% of the warming we're experiencing today, and there are other pollutants that make up the rest of the portion of warming we're experiencing. But these pollutants also work in different ways. CO2 lasts for hundreds of years in the atmosphere, and so it builds up over time and commits our planet to warming for centuries. I think 40% of the CO2 that we emitted in World War I is still in the atmosphere today, contributing to the warming we're experiencing today. So this is a long-term generation issue that if we keep emitting CO2 into the atmosphere, it will just commit our planet to warming for centuries to come. Methane, on the other hand, very different. Methane only lasts for around a decade in the atmosphere, but is a lot stronger at absorbing heat than CO2 is. So it packs a really powerful punch, but in a short period of time, because then after a dozen years, it's gone. So it doesn't commit us to warming for generations to come, but it contributes to a lot of the warming we're experiencing now. So we need a combination of reducing all types of pollutants, those that are long-lived, that we need to prevent from occurring, so we prevent warming in the long term and the maximum amount of warming that we have now, that we get in the future. But we also need to reduce emissions of the short-lived climate pollutants that could actually reduce warming in the near term during our lifetimes. So there's multiple pollutants. We've only even talked about the warming pollutants. There's also cooling pollutants. The warming pollutants far outweigh the cooling pollutants, but the point is we emit all different types of pollutants that interact with energy in all different ways. And these pollutants come from a number of different activities: power generation, transportation, residential appliances, farming, from the livestock, from growing rice, growing other crops, waste management, wastewater, landfills, fertilizer. There's just so many different activities that we do that emit these pollutants into the atmosphere. And to complicate it further, it's from all over the world. So almost every, I don't know of one country that doesn't contribute, but of course, some countries contribute way more than others. And so this is a real global challenge, and we need everyone to be on the same page to really tackle this and address it. So dealing with climate change and reducing our emissions requires a combination of different strategies. First are the innovative technology strategies. These are the things like renewable energy or capturing CO2 emissions before they're released into the atmosphere. There are so many promising technologies that will help us decarbonize society. But we also have economic incentives, making, for example, forests worth more alive than dead, or making companies who reduce their emissions benefit from that by getting more money for doing that. Then we also need strong policies at all levels: local, national, international levels. We need everyone to be on board because it is a shared atmosphere. And if the U.S. decides we don't want to do anything, but all the other countries are doing something, guess what? Our actions are affecting the entire world. And so everyone really needs to come together to be on the same page. But sometimes it's just being more efficient. We're smarter now than we were 5 years ago, 10 years ago, 20 years ago. And so sometimes it's as simple as just knowing there are better ways to do things that make it more efficient. So we're burning the same amount of material, but we're getting a lot more energy from it. There are a lot of types of solutions just like that just being smarter and implementing those changes could help us reduce our emissions. And finally, similar lines of just making smart choices. By being aware of the different options you have, you then know how you can make a better choice, because sometimes you have two options in front of you. Sometimes, fish, steak, oh, well, I don't really care which one I eat. But if you knew that the steak is a lot worse for the climate than the fish, and you didn't really care which one you ate, then eat the fish. Sometimes it's just being aware of things like that. So here's my super overwhelming slide of progress all around us. It's super overwhelming because there is a lot of good news and progress all around us. And so I'm happy to fill up this slide with all sorts of things. I actually had to cut a lot of things out of this slide because there's too much good news. And so there's a number of reasons to be hopeful. I just spoke about this crazy worldwide challenge that we have and how difficult it is. But there are organizations and companies and governments all over the world that are working right now to address this. So for innovative technologies, we've seen a total growth in the amount of renewables that we use, from wind power, from solar power. Solar prices are expected to be cheaper than coal within the next 10 years. We've seen Texas get more power, more electricity from wind than from coal. We've seen a number of other traditionally red states get a third of their energy from wind power. And we see this across the world too. We see a lot more solar and wind popping up. I think there's a new turbine coming off the shore of Scotland that in one cycle of the turbine spinning can power an entire home for a day. So we're making a lot of progress with this technology. We are also investing in a lot of experiments to try to understand how to separate carbon dioxide emissions from the rest of everything that we're emitting and then store them somewhere like underground. There are a lot of pilot programs around worldwide, currently very expensive, but there's a lot of attention focused on this because we don't understand how we can decarbonize society without doing that. So there are groups in Japan and Europe and in the US working on this challenge right now and making progress. Electric cars. Does anyone have an electric car? A few of you do. So electric cars are blossoming. You're all of a sudden starting to see charging stations pop up in different places, which is really exciting. You can save a lot of money from getting an electric car in terms of how much you'd spend on fuel. Electric cars are actually way more affordable than people think. It is a huge myth that they're super expensive. There are dozens of options on the market right now that are very comparable to what you get if you didn't get an electric car. Obviously, electric car using electricity, if your electricity is coming from coal, then, it's still a problem. But the point is that by having an electric car, you are enabling your energy to come from renewables, and you're building that infrastructure into your life for the future, or maybe even now. My husband and I, 100% of our electricity comes from renewables. And so if we had an electric car, it would come from renewables. But the point is that you have this great new technology that isn't relying on burning oil and gasoline all the time. And so it opens it up to other energy sources that you could have. There's also some really cool new food trends happening. I don't know if any of you have tried the Impossible Burger, the Beyond Burger. Anyone? A few of you. You guys have to, those of you who haven't tried it, which is most of you, it's delicious. I absolutely love them. You can get them at Bear Burger. Impossible Burger now has this whole Impossible Foods. And so basically taking a meat burger and creating it from plants. And you can get it rare or medium, and it looks like meat, and it tastes like meat, and it's not meat. So there's a lot of innovative technologies happening. In terms of economic incentives, we have carbon markets that are springing up all over the world: California, the New York area, China. And these carbon markets have shown to grow economies in the areas where they exist. So they're not hurting economies, they're growing economies. And you're putting a price on emitting pollution instead of just being free to emit whatever you want. We're also working on efforts to have the forests be worth alive more than dead, which I mentioned before. Part of this is by having a carbon market that includes credits from saving forests. This is in Brazil, but also deforestation is a huge issue in Indonesia. But organizations are working to turn that around. And of course, there's just incentives in general, as you would expect. My in-laws, for example, just bought a house that has solar panels on it. It wasn't even a choice. It was a requirement where they were, and they produce more energy than they need. So they sell that money back to the grid. They barely pay any money for their electricity. And so they're making money from that. Strong policies, we've seen an amazing amount of international agreements within the past few years. We had the Paris Agreement a couple years ago, the first time all nations came together to agree on a path forward. It destroyed records for the most amount of countries signing on in a single day. Of course, one country is not part of it right now. We are hoping to turn that around, but we will get there in a second to figure out what we're doing to work against that. So another international agreement that we are a part of is the Kigali Agreement, which is to phase out HFCs. HFCs are very powerful greenhouse gas. They come from refrigerators and air conditioning units, and we came together a couple of years ago to say that we are going to phase them out so that we no longer emit them. So this was huge. This was something that back in 2011, I was at the first conference meeting where it came up as a discussion at the Montreal Protocol meeting in Bangkok of what should we do about HFCs, and it was slammed down. So that was 2011, and now I think it was 2016 that all the countries, 195 different nations signed on to agree that we are going to phase out HFCs. And so the U.S. is currently the only country that doesn't want to be a part of the Paris Agreement. However, there are thousands of city mayors and universities and businesses, large and small, and governors that are on board to keep up with the commitments of the Paris Agreement. Kind of like we're going to ignore what the federal government is doing, and we're going to move ahead and do exactly what we said we would do, what we committed to do, and we are going to supplement the funding and help the Paris Agreement move forward. This movement is called We're Still In. I strongly suggest you check out their website. And then we also see a lot of public support for climate action, which is huge, because at the end of the day, the policymakers will respond to what the public wants. 80% of millennials want climate action, and there's some other interesting stats that I will also take my cheat sheet out. So every single state in the U.S., the majority of the state supports regulating CO2 as a pollutant, setting strict limits on existing coal-fired power plants, and requiring utilities to produce 20% of electricity from renewable sources. Every single state in the U.S., the majority want this. They want action for climate. Efficient systems, we are upgrading the whole electrical grid. This will be great for also including renewables into our existing infrastructure, but also just more efficient systems in general will just be more efficient at producing energy, which means less emissions. We also have a number of research teams trying to understand how to better manage livestock, just to, the types of food you give them or the amount of land you give them. All those decisions can play a role in how much greenhouse gas emissions are emitted from agriculture. And so just being more efficient with your system and setup can make a big difference. And cities, there's a lot of green infrastructure popping up. Did I do that? There's a lot of, even just having roofs have better drainage systems if there's more water, or having plants on them, or having coatings over windows to, keep some of the warmth in, for example, in a building. There's all sorts of new technologies that we've developed that we just need to employ, and that will also be more efficient. And then for smart choices, just very quickly, we all know taking public transportation when you have the option, switching out your light bulbs for more efficient ones like LEDs, the choices you make when you wash your clothes. If you can wash your clothes with cold water and it doesn't affect it, there's a lot of things you can wash with cold water that we wash with hot water. That is much more energy efficient. You also can hang dry clothes. Sometimes that's even much better for the clothing. So there's things like that that you can do to make a difference. And also just planting trees. An oldie but a goodie, and something that really does work. So, to recap, the first thing that we can do to stop this is reduce emissions. And everything I just mentioned is on that path towards reducing our emissions of greenhouse gases. But there's a second thing that we need to do, because some of the changes are already baked in. The sea level is not going to all of a sudden go down. The temperature is going to be where it's at, maybe a little bit higher, even if we stopped all of CO2 emissions tomorrow. And so what that means is we need to prepare for the changes that are already happening all around us. Things like developing our coastal houses on stilts. That's happening in a lot of locations that have had really bad storm surges from major hurricanes recently. The structures were wiped away. They're rebuilding on stilts. Also, trying to find more drought-resistant crops, things that grow better in different conditions. These are just two examples of many different options out there to adapt to a world that is warmer than what it had been the past several decades. And then finally, there are options on the table to manipulate the climate in the way we want to. Can we seed clouds? Can we grow them? Yes, we can. Do we want to? Probably not, but these options exist. We also want to figure out how to take CO2 out of the atmosphere. So that would fall into this category. You may hear about it as geoengineering, and there's a lot of interesting ideas out there. It's very scary. We would rather reduce our emissions and adapt to changes, but if we have to go in and manipulate parts of the Earth system to make it better for us, those options exist, the research is being done, and we would try to do it in the best way possible. So what can you do? This is the question that I always get, and it's very tricky for me to answer, because as you can tell, a lot of these are really large-scale, big changes on major levels of national and international agreements. So what can you do sitting here being alarmed by everything that's going on and wanting to leave here feeling like, how can I make a difference? The first thing that I always want people to do is just talk to friends and family about these things. Sometimes it's really hard to have the conversations with the family members who don't accept it or have heard something else or don't want to talk about it. But pushing yourself to have those tough conversations, I think, will slowly get us to change where we're at now to have even more people support climate action. And along those lines, voting is so important. I'm sure we're all in agreement now after what's happened over the past couple of years. And so having your voice be heard for something you really care about is incredibly important. And then there's obviously all these changes you can make in your life. You can install solar panels and have an energy-efficient home. You can make smarter dietary choices. Eating animals like cow isn't the greatest thing for the climate. Happy to answer questions about that after, but you can make different choices if it's something that you want to care about and want to do. You also can drive a better fuel efficient car. When you're searching for a car, look at the gas mileage. Try to figure out what are the options in my price range for the different types of gas mileage. Could I get a hybrid? Could I get an electric car? If not, what's the car that will be the most fuel efficient? And then of course, flying less if you can, and taking public transportation. Biking, I always laugh when I put that in here because you're not going to see me biking, so it's like, practice what you preach. I'm not biking to work. But these are all things that, depending on who you are and what you like to do, you can include them more in your lifestyle. But there are some really great calculators online where you can put in your exact data. You put in your zip code and you put in all the, how many cars you have and how big your house is and what you eat and all those things. It tells you what your carbon footprint is from each part of your life, travel and food and everything. And then it gives you a menu of different options that you could take to change your carbon footprint and drop it down. But it does it in a really quantitative way. So it shows by taking this action, you'll get this much benefit, but for example, taking a different action might not be as beneficial. And so this is my favorite one. I put the link up here. So I encourage you, if you really want to know what you can do, to look at how you're actually contributing and then the different behaviors that you can change. So thank you so much for your time. I really appreciate it. I'm more than happy to answer questions. There are 2 microphones in the aisles in the middle, and I would love to continue the conversation. Thank you, guys. Hi, yes.
Hello. Thank you very much for a really informative talk. I've taken notes, so many, and when I look around, I see many of us taking notes.
Great.
I wish my students would take notes like they're taking now. I do have a question about how were deserts formed and rainforests formed, and in which areas they were formed. Deserts compared to rainforests, how were they formed all over the world? And a corollary to that is, can we seed the clouds to get rid of some of the deserts?
Can we seed the clouds to get rid of, yeah. And so your first question was, how were rainforests and deserts formed?
In different areas of the world.
In different areas of the world. Very, very complicated question, because it depends on regional climates in terms of circulation patterns and how much moisture you get to certain parts of the world. So for example, most of the sunlight's coming at the equator, so it's very hot at the equator, and so then you have a lot of evaporation and all these storms, and then you have the air particles kind of go poleward, and then at some point they sink. And so there are parts of this whole process where there's just areas that are not getting much rain. And those areas tend to be some of our subtropical desert regions. And then there's some areas that end up getting a lot of rain. There also end up being the storm tracks from some of from the jet stream and from the polar air interacting with the mid-latitude air, creating the storm tracks, producing a lot of precipitation. And so you have more forests in those regions. So it really depends on all of these dynamics. And we're talking about like environmental science 101 that I haven't thought about in a really long time. But it's very interesting in terms of why different parts of the world are the way they are. And it really depends a lot on temperature and rainfall. So if you start looking at the different rainfall and temperature patterns in different areas, you can kind of figure out what type of climate it would be, and that would play a role of whether or not it's a desert or a rainforest. And then in terms of cloud seeding, it is something that we are technically capable of doing. Do we want to do it is the question. I would say absolutely not. I am very against tampering with the climate because when you cloud seed and you're creating more clouds that last longer, for example, you may be affecting rainfall in certain areas for communities that are farming there and rely on certain rainfall patterns. If we start changing properties, we don't really know what's going to happen, what those effects will be. It's very difficult with, scientists and labs, and you can reproduce conditions and see what happens. We can't experiment with the Earth. We have one Earth. So we can use computer models to try to figure out how different things would change, but there's a lot of things that we wouldn't know many of the consequences until we do it. So if we do things like that, we could make things worse for a lot of people, and we wouldn't know that until it's too late. So that's why technically, yes, we can, but do we want to? I don't want to.
So in the drought areas, if there is no cloud, how can we get a rain?
Okay, so what you're saying is for areas that may have drought, for example, how can you get more rain there? I think there's a lot of different types of technologies to get fresh water that don't include manipulating rainwater. For example, in the Middle East, They have great ways of taking salty ocean water and taking the salt out and using that for, for drinking and then for irrigation and that kind of stuff. So I would strongly suggest us trying to find those strategies rather than trying to change the atmospheric composition to create more rain. Also, in order for rain to fall, you need heavy cloud droplets. And so when you seed clouds, you end up with a lot smaller droplets. And so your cloud lasts longer, but it won't necessarily rain out. So just because we're creating clouds, it doesn't necessarily mean we're going to get rain.
Thank you very much.
Hi.
Hello. Why do you recommend that one thing we can do is fly less and yet take public transportation when flying is a form of public transportation?
Very clever comment. So when you actually look at the carbon footprint of the average American, the one thing that sticks out as our greatest contribution, more usually than our eating, is our flying, because we fly a lot more than maybe the average person does. And so it's often considered one of the better things you can do if you wanted to lower your specific carbon footprint to fly less, because you're having a lot more emissions coming from trying to fuel this heavy plane and get from one part of the country to the other. You have a lot more efficient transportation with trains and buses where you have a lot of people and it's not going as far, and it also can rely on more renewables. We have a lot of buses, for example, that run on electric power, and so we have all these different options for the other types of public transportation. Airplanes are way behind the curve, and we are trying very hard at my organization to change that. But until recently, aviation was the only sector that did not have a limit on the greenhouse gas emissions that they could emit. They didn't have any kind of international agreement trying to reduce their emissions. And so we've been working on other types of public transportation, but aviation's a little bit behind the curve. But thank you, that was a great question.
All right, thank you.
Hello.
Yeah. Hi.
I actually came with a few questions, but a lot of them were answered in the presentation, so thank you for that. One kind of separate from the entire issue itself, I talked to a lot of people who are interested in getting involved in different portions of climate science, but they're concerned about the job market and what kind of options are out there. What do you see in terms of funding, which I guess would kind of translate into jobs in hard sciences? What are you kind of seeing the trend is? Is it getting better? Is it getting worse? Is there a struggle in the job market there? If you could just expand on that a little bit. Thank you.
Yeah, great question, and it definitely depends on what country you're in.
Sure.
My husband and I were just talking to a few Italians who were saying that it's a struggle to get funding for research on these types of issues in Italy, but I know in France, for example, it's not at all right now. The French president is encouraging all that kind of research. In the US, it's interesting right now because it depends on which organization you want to work for. If you want to do climate research at the EPA, that is not the best place for you right now. But there are a lot of, for example, NGOs that are getting more funding because people are panicking about the state of the environment because of what's happening in the federal government. So we have no issue with our funding right now in terms of, trying to find more solutions, trying to work with more partners and businesses. We work with Walmart, for example, to reduce emissions. So it really depends on where you want to work, but I don't look at it right now as, there isn't that much funding. It's hard if you're interested in climate stuff. you could be a scientist, but you could also be plugged into the economics of the climate issue. You could be working on the policy side of things. There's so many different fields you can work on if you care about climate, that there seems to be no trend, of it, being not a good situation for those who are young and interested in getting into this field.
Awesome. Thank you so much.
Hi.
Hey there. So I'll start off with saying that, of course, I do believe in climate change. I didn't come here to be convinced, but you gave a great set of persuasive arguments. Here in the DMV, we've had an overstayed winter. What would you say to people who would use that experience to downplay or deny the effects of climate change?
Yeah, we see that all the time. I mean, just a couple of years ago, there was a bad winter, and someone in the government, who I will not mention, threw a snowball in the room and was like, climate change? How is it happening? It's snowing right now. And so there's a couple of responses to that when that comes up. And so one, it's that when we're talking about climate change, it is this global long-term trend. Of course, we're still going to have fluctuations in weather. And so, of course, we're going to have, it's not going to always be above freezing and never snowing anymore. On one hand, we have more moisture in the atmosphere, so it actually can snow even more when it does snow. What we are seeing is that the amount of cold outbreaks we have are declining, and the amount of hot events that we're having are growing. I think the amount of hot records to cold records, the hot records are 10 to 1 in terms of for every one cold record, there's 10 hot records. But also there's a growing body of research that shows that the warming in the Arctic and the reduced sea ice in the Arctic is actually playing a role with affecting the weather in the mid-latitudes. And the jet stream, which I'm sure we've all heard of, the jet stream is kind of like this atmospheric river air current. And the more temperature difference we have between the equator and the poles, the tighter that jet stream can be. But what happens when we're warming the Arctic so much, and as I said, we're, these large ocean areas that weren't exposed before are now exposed and are now able to absorb more sunlight, we're warming up the Arctic faster than the rest of the world. So now we're having this wavy jet stream. So it has kind of like this meandering path, and it's slow. And so what this means for our weather is that cold air in the Arctic that wasn't necessarily able to penetrate through that jet stream, that tight jet stream before, is now able to come down because we have this waviness that enables that cold air to come down. And so that's kind of if you've all heard of the polar vortex stuff that was in the news in recent years, that was kind of related to this, that we have these major dips in the jet stream that enable this cold air to penetrate into the mid-latitudes. So it's this long-term global issue. We can't pinpoint one area one day and say, well, it's cold here, or it's, this season was cold, so what's happening to climate change? It's what's going on across the whole world, which is a dramatic increase in temperatures. But also there is some evidence that a warming Earth, counterintuitively, will have some cold spells in Europe and the United States.
Okay. Secondly, thanks. Secondly, how do you feel about some of these recent trends that, they deny decades research science, i.e. flat earthers? How do you feel about that as far as alarming to you?
Sorry, I missed the last thing you said, i.e. what?
Flat earthers. It's kind of funny.
So just in general, like the deniers in
Yeah.
terms of, if you actually look at the data, it's a very small percentage of the United States that is very strongly denying climate change. Unfortunately, some of those people are in leadership positions, but the other ones are also in, just very vocal. So we hear about it more than, if the average person, even if they're not necessarily like climate change is a big deal, they're not necessarily like, oh my God, there's no way it's happening, it's God, it's all these things, like it can't be humans. Like they're, the fraction of people that really strongly believe what you're saying is only around 10%. But it definitely is a problem. I just always bring it back to, and I mentioned God, and I just want to say for everyone, like, I believe in God, so I'm not saying anything against religion. I think religion and science completely coexist. But humans, it's very clear that our human actions are influencing the climate and that we're capable of doing something like that. And so what do I say to some of that? I bring it back to the tobacco industry. It's a huge parallel with the people who cared about smoking and didn't want to lose their industries, pushed back really hard about the connection between smoking and cancer. It's really no different. A lot of the people that are strongly denying climate change are the people that are profiting from the fossil fuel industry, and so they don't want their businesses to go bankrupt. They've really profited from this industry, and so they have a lot of money, and they put a lot of that money into campaigns to spread misinformation. And so I always, when I'm faced with this, I always try to bring it back to something else that we can relate to, that we've seen this already, we've beat it before, we're trying to learn what we can from that and just kind of shift away from that type of thinking. But it's not an easy thing at all.
Thanks again.
Thank you.